Hey coders, everyone says Python is king, fast to write, easy to read. But what happens when speed really matters? Today, we'll look at a problem where Python chokes and C++ absolutely flies. Let's dive into the sliding window maximum problem, and I'll show you why C++ is the ultimate weapon here. Here's the challenge. You're given an array of integers and a number k. Your task is to find the maximum element in every subarray of size, k. It's called the sliding window maximum, and while the logic might sound simple, the performance impact is huge when n is large, like 10 million elements. Let's look at the C++ solution that solves this problem in ON time using a powerful data structure, Decay. We use a double-ended queue to keep track of the indexes of potential maximums inside the current window. If the element at the front is out of the current window, we remove it. Then, we remove all smaller elements from the back, because they're not useful anymore. Only the big guys survive. Finally, the element at the front of the decay is the maximum in the current window. This code runs super fast, under 0.2 seconds on arrays with millions of numbers. All right, now let's look at the Python version of this solution. We're using the exact same logic as the C++ code, just in a more Pythonic way, with the help of collections.decay. Let me walk you through this, line by line. Decay is our double-ended queue, and it holds the indexes of potential max elements in the current window. We loop through each number using enumerate, so we get both the index I and the value num. First, we check if the index at the front of the decay is outside the current window. That is, if it's I, k, or smaller, and we remove it. Then, we clean up the back of the decay. If any of those values are smaller than the current number, they can't be the max anymore, so we throw them out. After cleanup, we add the current index to the back of the decay. And once we've scanned at least k elements, we add the front value from the dec, which is the max of the current window, into the result array. The cool part is, the decay always maintains the max at the front, and we do it in linear time, ON. This is a super efficient approach. Now you might ask, if the algorithm is optimized, why is Python still slower? Here's the thing. Python is interpreted, not compiled. Every loop, every comparison, every object access is a bit slower. In C++, we're working with raw memory and compiled machine code. In Python, there's an interpreter doing all the work, dynamically. On big arrays, say 10 million elements, the Python version takes 2 to 3 seconds. But the C++ version can do it in under 0.2 seconds. In performance-critical systems, like trading engines, game loops, or embedded systems, that's a deal-breaker. So yeah, Python is beautiful and expressive, but not always the right tool for the job. So there you have it, the sliding window maximum problem in both Python and C++. Same algorithm, same logic, but very different performance. Python is amazing for quick scripts and readability, but when you're working with huge data, real-time speed, or tight system constraints, C++ just dominates. That's why smart developers know the best language depends on the job. Let me know in the comments, do you prefer speed or simplicity? And what other problems should I test across multiple languages? If this helped you or taught you something new, please give the video a like. Subscribe for more real dev breakdowns, coding challenges, and cross-language battles. And don't forget to hit the bell so you never miss the next drop. Thanks for watching, BI Code, and I'll see you in the next video.